When we say 5 squared, it can also be written as what? 5 times 5. When we say a cubed, it is also what? A times a times a. Now, in these two scenarios, 5 or a can be referred to as what? Base. While 2 and 3 are referred to as what? Either your exponent or index or power. Depends the one you want to use. Hi, my name is Faithful and welcome to Alpha Space, where we simplify maths, physics and chemistry for students like you. Let's look at the rules for working with indices. So, we'll be looking at the rules for working with indices. The first rule states that if I have a raised to the power of m multiplying a raised to the power of n, it is what? A m plus n. This is your multiplication rule. Now, what it simply means is if I have a term a raised to the power of m multiplied by another term a raised to the power of n, it is the same thing as what? A m times n. So in order to follow your multiplication rule, the bases must be the same. So the base must be the same. Irrespective of whether the powers are the same or not, the base must be the same. Now, this is rule number 1. For the second rule, let's assume something. I'll write it this way, rule 2. For the second rule, I want us to, what if I have a scenario where I say 5 raised to the power of 3 divided by 5 raised to the power of 2. Now, it is the same thing as me saying 5 times 5 times 5 divided by 5 times 5. Now I can cancel, obviously. Can cancel. And my final answer will be what? 5 over 1, which is equal to what? 5. Now, you can work with this comfortably. What if I give you a scenario where I have 5 raised to the power of 17 divided by 5 raised to the power of 15? Now, in this scenario, this will be very bulky because I'll have to write 5 17s divided by 5 15s. So this work will be very bulky. So we have now lessened the work. And the rule 2 states that if I have a scenario, rule 2, a raised to the power of m divided by a raised to the power of n, it is the same thing as me saying a raised to the power of m minus n. And this is your rule number 2. Looking at examples concerning the two rules we just learned. Now, the first one says 5 raised to the power of 3 multiplying 5 raised to the power of 4. Now, this is very easy. This is a raised to the power of m multiplying a raised to the power of n. And the base are the same. So we just have 5, 3 plus 4. And our final answer will be 5 raised to the power of 7. In this case, if I have 6 raised to the power of 5 divided by 6 raised to the power of 2, this is the same thing as me saying 6, 5 minus 2. And obviously 5 minus 2 is what? 3. So it will be 6 raised to the power of 3. For rule 3, I'll write it here, rule 3. Let us look at this case. Let's say I have 8 raised to the power of 2. We all agree that it is the same as 8 raised to the power of 2 times 8 times 8, isn't it? Now, if I put it raised to the power of 3, it is this case is trying to tell me I should do 8 raised to the power of 2 twice. So let's assume you only know the rule 1 and rule 2, which is your multiplication rule and your division rule. You can use your multiplication rule to get the answer to this. So the rule 3 states that, I'll write it like this, rule 3, if I have a term a raised to the power of m or raised to the power of n, it is the same thing as me saying a raised to the power of m n. So meaning the terms here, the powers, will multiply each other. So this case, you should be able to solve it because why? Instead of going through this long route, I will just say 8, 2 times 3, which is what? 6. And therefore, my final answer will be 8 raised to the power of 6. Although if you follow your multiplication, it can be 2 times 2 times 2 plus 2 plus 2. It will be what? 6. But if you follow it faster like this, you get this. And this is your bracket with power rule. Your bracket with power rule. So let's look at rule number 4. Rule 4 is also known as your power with zero rule. Your power with zero rule. Now, before I tell you the rule, I want us to understand the rule first of all, or how we came about the rule. Now, the rule came from rule number 2, which is your division rule. Now, let's assume we have 5 raised to the power of 3 divided by 5 raised to the power of 3. Can all agree that this, based on rule number 2, is the same thing as me saying 3 minus 3, which is equal to 5 raised to the power of 0. And this will be our final answer for someone that only knows rule number 2. This will be his final answer. Now, in this case, if we follow the long route that we're trying to shorten, we'll have 5 times 5 times 5 divided by 5 times 5 times 5. So 5 cancel 5, 5 cancel 5, 5 cancel 5, and this is 1, 1, 1, 1, 1, 1. So 1 times 1 times 1 is equal to 1 all over 1, which is equal to 1. So these two answers are not the same. So the rule number 4 states that a raised to the power of 0 is equal to 1 as long as what a is what not equal to 0. So where a is not equal to 0, a raised to the power of 0 is equal to what? 1. So a cannot be 0. A cannot be 0. So you cannot have 0 raised to the power of 0. This is wrong. So a raised to the power of 0 is equal to 1. So therefore, the final answer here is not supposed to be 5 raised to the power of 0. But the final answer is supposed to be what? 1. And this is what? Your power with 0 rule. Now, still from rule number 2, which is your division rule, if I have a case where I say 5 raised to the power of 6, 5 raised to the power of 2 divided by 5 raised to the power of what? 6. Now, this will be the same thing as me saying 5, or let's shorten the number, 5 raised to the power of 3. It will be the same thing as me saying 5. If you know your division rule, it is the same thing as me saying 5, 2 minus 3, which is equal to what? 5 raised to the power of negative 1. Leaving this answer like this is not right. Now, based on this long form method that we are trying to simplify, that we are trying to shorten, I can do this as 5 all over 5 divided by 5 times 5 times 5. And this is 5 cancel 5, 5 cancel 5. This is the same thing as me saying 1 all over 5. Now, this is totally different from this. So your rule number 5 is called what? Your negative index rule. Your negative index rule. So what it says is that if I have a raised to the power of negative 1, it is the same thing as me saying 1 all over a. So this is what rule number 5 says. So now let's look at example concerning all the rule number 3, rule number 4, and rule number 5. Now let's look at the examples. As we all know the rules, this is your bracket with power rule. So when you have something like this, what do? You multiply their powers. The power. So it will be 2 times 4, which is what? 8. And your final answer was 6 raised to the power of 8. You can express 6 raised to the power of 8 on your calculator and give the final answer. Good. Now, this is a raised to the power of 0 because we have 1 all over 9 raised to the power of 0. It's the same thing as your power of 0 rule. This is a raised to the power of 0. As long as this is not 0, it is what? 1. Now, the next one is what? 1 all over 2 raised to the power of 3. Obviously, from your negative index rule, 2 raised to the power of 3 is what? 8. And this is what? 1 all over 8. So, on your calculator, punch 6 raised to the power of 8, and this will be your final answer here. So, let's look at the next rule. So, we'll be looking at rule number 6 and 7. Now, rule number 6 and 7 are referred to as your fractional index rules. Your fractional index rules. Now, for rule number 6, before we go into giving you the rule, so that we don't just give students the rule, we want you to understand the rule. Now, for rule number 6, if I have 9 raised to the power of 1 all over 2. And you look at this. On mere looking at this, you just only know the other rules we've taught. From rule number 3, I can do something to try to understand what this rule is all about. I can square it. Now, once I square it, you know from rule number 3, you are meant to multiply the powers. So it's the same thing as me saying here, I'll do it here. Same thing as me saying 1 all over 2 times 2. Now, this is 2 cancelling this 2, and this is what? 1. So this is the same thing as me saying 9 raised to the power of what? 1. If, for example, in mathematics, we all know that if I have 9 all squared and I square this bracket, this 10, I will have what? 9. So now, the rule number 6 states that what? If I have an expression a raised to the power of what? 1 all over n, it is what? The n square root of what? A. And this is what? Rule number 6. If I have a raised to the power of what? 1 all over n, the same as what? The nth root of a. The nth root of a. So let's look at rule number 7. I'll look at examples concerning all the rules we've learned. Now that we all know rule numbers 1 to 6, now for rule number 7, let's assume we have 8 all squared 2 all over 3, like this. And we are given something of this nature. If I have this kind of scenario, I can make it to be, this 2 all over 3 can be written as what? 1 all over 3 times 2. It is the same thing as this, isn't it? So I can now write this as 8 1 all over 3 all squared. Now, don't forget, this is your rule number 6. So I can write this as what? The cube root of 8 all squared. Now, this brings us to what? Rule number 7. Rule number 7, it states that what? If I have a raised to the power of what? M all over n, it is what? The nth root of a all raised to the power of m. And this is your rule number 7. So now let's look at examples. As we have all learned these rules, let's look at examples concerning them. Now we are given all this to solve because we all understand the rules now. The first one, let's solve the first one. For the first one here, we can start solving it gradually. What do we see? We see that these powers are what? But we have a negative sign. So the first thing we can do is removing the negative sign, because students tend to become scared whenever there's when a negative involves a question. So when we have this, we can have 1 all over x cubed raised to the power of what? 2 all over 3. Now we have done the first step. Let me write it here. Negative 2 over 3. Now, since we have done the first step, it will be very easy. Since we are meant to multiply the powers, we'll have 2 all over 3 multiplying what? 3. And this 3 will cancel out this 3. So therefore, my final answer is what? 2. 2. I will have 1 all over x raised to the power of 1. 2. And this is my final answer. You see how big it is, but you see how we have simplified it. Let's look at the third question. The third question says negative 343 all raised to the power of what? Negative 1 all over 3. Now, since we have this, the first thing to do is removing the negative sign from the exponents. So we have 1 all over what? Negative 343 all raised to the power of what? 1 all over 3. And we know this will be quite easy. Now, there cannot be a negative of roots. So if you have root of -1 in real numbers, not complex numbers. In real numbers, it is not logical. So what it therefore means is this negative, don't forget, is both for the numerator and the denominator. So it will be -1 all over the cube root of what? 343. Not that we remove the negative, but what it means is the negative will only affect this equation if the square root were meant for the numerator and the denominator. The square root, the negative is both for the two of them, so it does not affect only this. So we can write it as this. Now, if you point your calculator, the cube root of this is what? 7. And my final answer will be what? 1 all over -1 all over 7. And this will be my final answer. Now, I intentionally left number 2 because I want you guys to solve it. Solve it, drop your answer in the comment section. I'll be glad to respond to you. Thank you. Please like and share and subscribe. Thank you very much. See you in the next video.